Enantiomeric excess continued. This makes our previous activity relevant. Without this, it was just a bunch of work. So we give you conditions again. I will remind you that this is how many grams? Careful. That's 1,500 over 1,000, right? That's the same as 15 over 10, which is the same as 1.5 over 1. 1.5. What's a better way to say 1.5? 3 over 2, exactly. Okay, that's the grams. This is the, guys, this is the reference rotation. You didn't have one last activity. This is new. You have to be given this for this type of question. So it's in a book. Books that have tables of things. And 10 mils is the L, isn't it? Need a new color for L. What are the units supposed to be for L? Not milli, no, that's not L. Sorry. Centimeters is L. Yes, there was good confusion going on there. He was talking nonsense. That's the path length right there, 40 centimeters. How many decimeters is that? 4.00 dm in blue. And this is just the alpha observed. Our first job is to standardize alpha observed. And we need one more color, pink. That is the volume, right? And you use it as is. And this is my pattern because in the lab, we use milliliters all the time. The only reason we use decimeters is for these people. Otherwise, that's not my first choice. But, you know, the people that do rotation, they came up with the standards. We got to go with their standards. And they got to use grams. So I am going to standardize my observed rotation. Do not use that negative 240 at all. It has nothing to do with this problem yet. So I need the based on this thing that you have to learn, alpha observed on top over C times L. Alpha observed is 30 plus 30. If it's straight from the question, I'm going to put it in black. And the volume was also in black. Didn't have to edit it. So I need the grams here. Should write it more like a fraction. There. And the path length is here. Simplifying, how about 30 over 3? I think that's a big help. Yes, sir. Uh-oh. The 30 is the observed rotation. I'm standardizing that value so I can compare it to a literature value. Otherwise, they were done under different conditions. There's too many variables, and the comparison is a waste of time. So I gotta get it to the same conditions that the people that published it put it under. And that's all this is for, this first exercise, part A. And then the 30 over the 3 is a 10 over a 1. The 4 over a 2, yes, that 4 becomes a 2 when it cancels this 2. And writing down what we're left with, 10.0 degrees over 1 over 10 times 2. Blue 2. I think we can still simplify. You can do the bottom, 10 over 2 over 10 is 1 over 5, or the top, 10 over 2 is 5 over 2. They're both going to help. Do one or the other. 10 becomes 5. 2's gone. 5.00 over 1 over 10. What you got? 5.00 times 5. Times 10. What am I saying? 5. I don't know what that is. Times 10 over 1. 50. That is your alpha observed in a standard format. So I know right away this stuff's not pure because I didn't get the number 240. If I had got the number 240 or negative 240, one or the other, this stuff is pure. And I promise you on your test, it will never be pure because the question's just, it's too easy. Sorry. You're not showing me the skills you know. Okay, so it's never going to be pure. Here's a new equation you got to learn, and it's easy to remember this one. Percents are always the amount you got over what you could have got times 100. You just calculated the amount you got. So percent EE, easy equation, equals the standardized observed rotation you just calculated over the standard of reference rotation. We want all of our numbers to be positive. So how did I make sure of that? Absolute value. Okay. What did you get? You got 50 from the previous part. Oh, 50, not 5. Over 240. I swear it was nicer math when I did it upstairs earlier, but you know, I may have made a mistake in my haste. Any simplifications? This is not as nice an answer as I was shooting for. 50 over 24, I don't know. It's 5 over, 240. Yeah, I didn't even copy it right. It's already nasty enough, and now you're not copying it right? Good. 240, negative 240, right? I can divide by 2. I like it. So that'll give me a 25 on the top. And a 12 on, 120 on the bottom, right? I could have done other stuff. I know. But, you know, simplifying is up to personal preference. That's all. Let's just write down what we have so far because it's getting a little messy. 25 over 120 times 100. Definitely divide these both by 10, right? It's not letting me change color. 10 and divide by 10 is 12. And 10 and 12 both divide by 2. I could have done better, huh? 5 and 6. 25 times 5 over 6 is now what I got. Man, well, what's 25 times 4? That one you should know. 100, and then I had 25. 125. And I really, this is very rare that you ever have to do this. She's already worked it out for me. Yeah, I'm doing long math here. Oh boy. 2, 12, 0, 5. And it's not even writing nice. That's 5 there. And I mean, guys, if you call it 21, I'm happy. 5 goes into 6 1. You're close enough if you say 21 right now, right? You know it's a little less than 21, right? It's not quite 21, but I'm going to take 21. And it's very rare you have to do any estimating. That's not a degree sign. Hey, use your units intelligence. The degrees were in here and they canceled, right? Percentages don't have units, they're percent. 21%. Okay? We'll interpret what that means in a second. There's only one meaning. You have 21% more of the major than the minor. That's the only meaning for this number. You have enough to figure out how much percent of each isomer you have now. You do. Part C. Part C doesn't start till now. This was all part B. 21% EE means 21% major. And now you have to watch your words. In fact, we don't even know the word. Well, that's not this. What's 100 minus 21? Yeah. Please don't. I mean, if you listen to yourself and you said, he must be saying 21% major, 79% minor, right? Did you just hear what I said? Those words can't be spoken. Major is always more than minor. The word I need for the 79% is, that's the part of this mixture that doesn't rotate light, because there's equal amounts of one isomer doing that and the other isomer doing that. So that part, 79% of the solution, is behaving like it's not there. That's the zero. There's no rotation when you have equal amounts of two enantiomers. What I forgot to in the previous video, when I was verbally talking about it, was to say that mixture is called a racemic mixture. And students always say race-mic because that's how it's spelled. But it's racemic. Here's the spelling. All you saw was the excess that rotated the light. The part that doesn't rotate light you don't see, because it's canceling each other. Can you break down 79% racemic for me? What percentage major, what percentage minor in 79%? What's racemic mean again? From the definition, you can tell me. And somebody already said 39.5. Yes, that means you get 39.5% more major. More major, you don't have to write the word more. And 39.5% minor. Hey, now your totals work out. 60.5% major. 39.5% minor. What's the difference between 60.5 and 39.5? You better give me 21, or else you did it wrong. You don't like this way? You can do this way. Strict math people, I've never had a student do it this way, but there's two components to your mixture. Therefore, A plus B equals 100%. A minus B equals 21. Go ahead and solve. Two equations, two unknowns, you can solve. You're going to get 60.5 and 39.5. I promise. This way is better because it actually uses the racemic conceptually to do the math. So we're almost there. We have two things to do. One, we could have done before the activity started. Determine which one's major. I go to the start, no math. Determining which one's major depends only on this and this. What did I just highlight? The sign. If signs don't match, HFM is minor. If signs do match, HFM is major. Which one's true in this example? First sentence or second? First sentence. Half the time it's the first sentence, half the time it's not. You know what irritates me now that I've said this? I got the two scenarios that cover every possible situation. I'll still get this question. What happens when this one's positive and this one's negative? They think it's a different sentence now. It's not. They don't match. Same scenario. What happens if they're both positive? Which of the two sentences is appropriate? The second one. If they're both negative, the second one. Okay? I've covered all four scenarios with two sentences. Okay? So I don't want to hear what happens if. You're either the top one or the bottom one. End of story. Okay? So, which of these two numbers do I care about? The 39.5. HFM. I didn't even have to figure this out. I kind of wasted a little time, but you know, it's an introduction. Now the fun part. It's not hard doing percents like this. You guys are all freaking out. I don't know how to do 39.5. That's insane. Do you know how to do 40? That's 10 plus 10 plus 10 plus 10. That's easy. What's the total milligrams? I need it. I can't read it. It's at the top of the screen. 1,500 milligrams. I need 10%. I need 10%. I need 10%. And I need 10%. What's 10% of 1,500? Guys, move the decimal one time. 150. And if you're like me, all I'm doing is this. I'd probably give you, if it's a 3-point question, I'm just giving you 2.5 out of 3 right now. I mean, you're darn close. 40% is not 39.5, but it's darn close. What is 1%? Well, if you need 10%, you move the decimal again, right? Well, what is 0.5%? Why did I do 1%? Because 0.5 is half of that. That's 592.5. And I purposefully chose an example that's harder than the one that will be on your test. If you can handle this, you will be able to handle the one on your test easily. Okay? Remember, you do get partial credit for setting it up right. And I do want to say something. Some students are terrified by this question. It's okay, I understand. Fractions are never were your friend. So what you do, if you know your answer for part A is ridiculous, you don't stop. Invent an answer less than 240. Why is it not a good idea to invent an answer greater than 240? It is not possible to have more than 100% pure stuff. In your next equation, you're using 240 in the denominator. So when you're totally blitzed on part A and I know I did something terrible because this answer makes no sense. Invent an answer with the same sign as here that's less than 240. Carry it through to the next part. If you do that properly, you get 2 out of 2 for the next calculation. And if you do the next part properly, you get 3 out of 3 for that. And the only point you lost, or maybe 2, if you made 2 mistakes in your setup, is 2 points or 1 point. You can still recover. Are we clear? So don't, A is going to be the one that might give you trouble. I'm just saying that. Invent an answer. If you set it up properly, you get full points for setting it up properly. Everybody should do that. Okay? Give me the wrong answer and cross it off and invent an answer. If you know your answer is wrong. Okay? That's just strategy, guys. Strategy. And that's the end of our activity. Make sure you got it all. I need everything that's highlighted, and I need the work too. Pretty much everything you see. There you go. A little small. And we're done.